Okay, in our next video here, we have an ambitious set of multiplications to take care of, but multiplication is really not that bad. Again, if you multiply two complex numbers in standard form, the result will be a complex number in standard form as well. The one item that we'll want to keep in mind when it comes to multiplication of two complex numbers is this rule. The alternate form of our definition of a complex number says that if we take the square of I, which is the square root of negative 1, we get negative 1. So how does this happen? Well, in this case, let's think about the square root of negative 3 times the square root of negative 27. Because there are negatives under the radical, we must extract I from each of them. So in other words, this is actually I times the square root of 3. Remember that as an in-between step, you could treat this as the square root of negative 1 times the square root of 3. And we're going to have I times the square root of 27 that we're multiplying it by. We must handle these roots, and we must handle I first before we can multiply the radicands using our radical rule, which is to say that we're going to have I squared multiplied by the product of 3 times 27 under the radical. Well, what is that? Let's see. I squared, remember, that's negative 1. And we're going to be multiplying that by the square root of 3 times 27, which is 81. Well, the square root of 81 is 9, so we actually get negative 9 as our result. And now my pen's going nutso here. Okay, so that is our result. Okay, so that's one type of multiplication right here. And we note that when we take our square roots of negatives right here, remember I comes first. So how about this next one? Well, this one looks a little bit more difficult. We've got a complex number in standard form times another complex number in standard form. If we're going to multiply this in a way that's very similar to our polynomial multiplication, we might use our FOIL method to multiply this out. That is to say, we're going to take our real part times our real part. Our first term is 5 times 6, which is 30. We distribute 5 to our next term, negative 2i, so we're going to get negative 10i by multiplying 5 times negative 2i. And then we're going to take, just write an arrow over here, then we're going to take our inner terms, which is positive I times 6, so we distribute I to 6, we get plus 6i. And then we multiply our last terms, I times negative 2i, so that is minus 2i squared. And of course, if we combine our like terms right now, we've got 30 minus 10 plus 6, so minus 4i. But then we go to our definition again right here that says anywhere we see I squared, we replace it with negative 1. So we've got minus 2 times negative 1. And this is actually easier to resolve now because now we've got 30 minus 4i plus 2. And following our order of operations, we'll end up with 32 minus 4 times I as the result. All right. Well, sooner or later we had to come across some fractions, so let's try one with fractions right here. Everything works the same way. We'll use our FOIL method, 4/7 to 7/5. So let's see, we're going to get 4/7 times 7/5. We're going to get 4/7, our outer terms, times negative 7/10, so minus 4/7 times 7/10 I. We're going to get plus 2/7 I times the next term 7/5. And then we're going to multiply our last terms, which is plus times, positive times a negative is negative. Right, there we go. So positive 2/7 I minus 7/10 I is minus 2/7 I times 7/10 I. I'll put a parenthesis around this so we recognize that we're actually multiplying these guys together right here, and we're adding and subtracting each of these terms as appropriate. So 4/7 and 7/10, 4/7 and 7/5. Okay, all of these are multiplications right here. So how do we handle it? Well, remember, we don't have to multiply numerator to numerator, denominator to denominator, if we can cancel across a division symbol or a multiplication symbol. So 7s, those cancel, leaving us with 4/5, not leaky pen fifths, 4/5. The 7s reduce here, and of course so do the 4s, so 4 and 10 actually reduces to 2/5, and that's times I as the middle term, plus 2/7 and 7/5. The 7s cancel here, leaving us with plus 2/5 I. Oh, this is going to be interesting. And 2/7 and 7/10, well, the 7 cancels, the 2 cancels with the 10, leaving us a 5. So we're going to have minus 1/5 I squared. Ooh, this is interesting. So what are we going to get? 4/5 minus 2/5 plus 2/5 I. That just goes away. 1/5 times I squared. Remember, that's 1/5 times negative 1. Of course, the negatives change the sign right here, so we end up with 4/5 plus 1/5. Adding the numerators over the common denominator gives us 5/5. Well, that's just equal to 1, so there's our answer. Okay, let's see if we can handle one more right here. This time, 1 minus 7i and 1 plus 7i. Well, in this case, 1 minus 7i, 1 plus 7i, when we multiply that out, this is the form, this is one of those special factoring forms, right? A minus b times a plus b. The sum and difference of binomials turns out to be a squared minus b squared. So what does that mean for us? Well, that means that we're actually going to have 1 squared minus 7i squared. So what is that? Well, 1 squared, of course, is 1 minus 49 times I squared. And if you recall, I squared is negative 1, so we're ending up with 1 minus 49 times negative 1. And this becomes 1 plus 49. So our answer here is 50. Now, in complex numbers, in its standard form, this is 50 plus 0i. So it can happen that we get those. Okay, more stuff in the next video.